Hello students, welcome back to our class. Let us continue with the problems which were given in previous board examinations. See here, there is a problem given that is a circle and this is one tangent and this is one more tangent drawn to a circle, and of course you can identify one triangle also over there. So this is the triangle. Let this triangle be, for example, triangle ABC, and this is the point of contact. Let us say this point is equal to some R, and this point of contact is P, and this point of contact is going to be Q. And what are we going to prove in this statement? See, in this statement, ABC is a triangle, and one of the sides of ABC, that is BC, is tangent to the circle, and the sides AB and AC are produced or extended. Then the side extended intersecting or touching the circle at a point P, as well as when you produce the side AC of triangle ABC up to Q, then that AQ would also be the tangent to the circle. So here we are going to prove that from the adjacent figure, we need to prove that perimeter of triangle ABC is going to be 2 times AP or 2 times AQ. That is what we are going to prove. So in order to prove this perimeter of triangle ABC, what do you mean by perimeter of a plane figure? So perimeter means length of the boundary is said to be the perimeter, right? So length of the boundary means, since ABC is our plane figure that we are going to find out the perimeter of triangle ABC. So length of the boundary of triangle ABC means AB plus BC plus AC is the perimeter of triangle ABC. Okay, before finding the perimeter of triangle ABC, what else you can identify from this adjacent figure? See, if you would observe that point B as well as the point C, we can treat points B as well as point C, and of course the point A as the points drawn or plotted exterior to the circle. So you know that the tangents drawn from an external point of a circle are equal. So what are the external points? Let us try to identify. First of all, A is the point which is exterior to the circle. So from that point A, there are 2 tangents drawn to the circle. What are those 2 tangents drawn? AP is one tangent, AQ is one more tangent. So tangents AP and AQ both are equal according to the property. So that is the first thing we identified. And the second thing is, from point B also we identify 2 tangents. What are those 2 tangents? BP is one tangent and BR is also one more tangent. So that BP is equal to BR. Similarly, from C also we can identify 2 tangents. They are CR is equal to CQ. So totally from A and from B as well as from C, we could observe tangents drawn from external points of a circle are equal. So let us try to write that information. See here, in order to simplify or in order to prove this perimeter of triangle ABC is equal to 2 times A into AP, these points are very much important and these points are very much useful in fact. So I am going to write the statement: since tangents drawn from an external point, of a circle are equal, we can say that from A, AP is equal to AQ, that is the first thing. AP is equal to AQ. What is the second one? That is BP is equal to BR, BP is equal to BR, and what is the third one? Third one is going to be CQ is equal to CR. CQ is equal to CR. So this is what the information that we obtained from the given figure. Let us get into the problem. So what is the problem here? Consider LHS. So what is LHS? That is perimeter of triangle ABC. Okay. So perimeter of triangle ABC is going to be, what do you mean by perimeter? Sum of lengths of all the three sides. So AB plus BC plus AC, right? So AB plus BC plus AC or CA, which is equal to AB is AB, and what is BC here? BC is going to be BR plus RC, right? So BR plus RC plus CA is CA only, okay, which is equal to AB is AB plus BR. Instead of BR, can I write BP, right? So which is equal to BP plus RC. So instead of RC, can I write CQ? Yes, of course, CQ, and CA is CA only. Once you observe here, this is AB plus BP. AB plus BP, when I am taking them together, AB plus BP is going to be AP, which is equal to AP plus CQ plus CA. CQ plus CA is going to be AQ, is equal to AQ, which is equal to AP is AP, but instead of AQ, can I write AP again? Of course, I can write. So AP plus AP is going to be 2AP. Therefore, perimeter of triangle ABC is equal to 2 times AP, which is equal to 2 times AP. So this way we can easily prove this statement. Hope you understand, right? Yes. Let's move on to the next statement. The next statement is going to be, for example, there is a circle, right, and a quadrilateral is circumscribing a circle again. So this is a quadrilateral circumscribing a circle, whatever the quadrilateral is. So I am taking, this is one quadrilateral circumscribing a circle. See here, in this quadrilateral circumscribing a circle, this is the point A and this is point B, and of course this is C and this is D, and this is the center of the circle. Let the center of the circle is equal to some O, and here the point is AB and CD are opposite sides of the quadrilateral circumscribing a circle. Similarly, AD and BC are also the opposite sides circumscribing a circle. But here the point is opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Hope you understand what is the statement is going to be proved here. Opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center. It means AB and CD are opposite sides. So AB side is subtending an angle at the center. So this is what the angle made by AB at the center. So the side opposite to AB is CD. So CD is one more side which is making another angle at the center. Now you are going to prove that this angle plus this angle is equal to 180 degrees. Otherwise, you can identify AD and BC also, and you can prove the same statement by taking AD as well as BC. It means AD is making an angle at the center. This is the angle made by AD at the center, and this is what the angle made by BC at the center. So you can even prove that sum of these two angles is also equal to 180 degrees. But how is that possible? And before that, you please do remember what is the statement of the theorem. So the statement of the theorem is opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center. Opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. It means you are going to prove that angle AOB is equal to angle AOB plus angle COD is equal to 180 or angle AOD plus angle BOC is also equal to 180 degrees. So that is what I am going to write here. What is the statement? So the statement here is ABCD is a quadrilateral circumscribing a circle circumscribing a circle, then prove that angle AOB plus angle COD is equal to 180 degrees. Okay. So, in order to prove that it is 180 degrees, of course, it is pretty much easier that let us consider points of contacts. So, these four are the 4 points of contacts. Let this point of contact be P, and this is Q, and this is R, and this is S. So, these 4 are 4 points of contacts, and I am going to join this P and O, as well as going to join O and Q, as well as O and R, as well as O and S, right. After joining them, already we proved a set of pair of triangles which are congruent by RHS congruence. Have you remembered that? So, I am going to use the same strategy in order to prove this also. Once you observe this angle is equal to 90, this angle is also equal to 90. If you once observe a triangle POB and QOB, triangle POB and QOB, those two triangles are congruent by RHS congruence. You know why? Angle P is equal to 90, here also it is equal to 90, and OB is equal to OB, that is the common hypotenuse. OP is equal to radius, OK is also equal to radius. So, triangle OPB is congruent to triangle OQB by RHS congruence. Not only triangle OPB as well as OQB. Similarly, triangle OQC and ORC also congruent by RHS, and ORD as well as OSD also congruent by RHS congruence, and OPA as well as OSA also congruent by RHS congruence. So, that is what I am going to write here. So, first thing that I observed that here there are 4 pairs of triangles are congruent by RHS congruence, right. So, we observed that let us start from here. Okay, OPB triangle OPB is congruent to triangle OQB, and now let us go in this direction. It is a clockwise direction, right. So, OPB congruent to OQB and OQC congruent to ORC, triangle OQC congruent to triangle ORC, and then triangle ORD congruent to OSD, triangle ORD congruent to triangle OSD, and then triangle OSA congruent to OPA, triangle OSA congruent to triangle OPA by RHS congruence, So, since all the 4 triangles are congruent to 4 respective triangles, then by CPCT, this is what the very important point that we are going to identify. By CPCT, we can say that, observe here, since these 2 triangles are congruent, this particular angle is equal to this angle, right, and this angle is equal to this only angle, and this angle is equal to this angle, and this angle is equal to this angle, right. Already we proved that they are congruent. So, once you observe, all these angles at a point O add up to 360 degrees, as you are all aware of that. So, we can say that x plus x plus y plus y plus z plus w is equal to 360 degrees. Okay. There are 2 x's, 2 y's, 2 z's, 2 w's. So, that I am going to take 2 common, then it would be x plus y plus z plus w is equal to 360. But 2 into how much is equal to 360? 2 into 180 is equal to 360. So, what does it mean? X plus y plus z plus w is going to be 180 degrees. But what is this x, y, z, w? Let us go to the figure. See here, we need to prove angle AOB and COD is equal to 180 degrees, right? What is this angle AOB? When you observe, this is what the entire angle AOB. So, this entire angle is the sum of x as well as w. So, we have x and w, writing them together, plus remaining things are y plus z, right? So, y plus z. Now, I am going to write x plus w. Instead of x plus w, can I write AOB angle? So, angle AOB plus instead of y plus z. Once you observe, this is what y plus z, right? So, instead of y plus z, I am writing angle COD, which is equal to 180 degrees, right? So, this way we can prove this statement easily. And here the point is ABCD is a quadrilateral circumscribing a circle. Then we should prove that opposite angles subtend supplementary angles at the center. So, let us move on to the next statement. So, the next statement is very important for, of course, for 4 marks, okay, in essay questions. So, that we are going to prove that statement. So, what is the statement is all about? So, the statement is going to be, there is a circle and now the circle is inscribed in a triangle, right? So, this is a triangle. And observe that this is what the triangle is. Let the triangle be ABC triangle and radius of the circle is going to be 4 centimeters. So, this is 4 centimeters. Let the radius OD is equal to 4 centimeters and the length of BD is given 6 centimeters and the length of DC is given 8 centimeters and radius is equal to 4 centimeters. Now, here in this you need to prove or you need to find the lengths of AB as well as AC. Hope you understand what is the statement. From this adjacent figure, so you need to prove that you need to find the values of AB as well as AC. So, how to find the lengths of AB as well as AC from this adjacent figure? So, once you observe here, in this particular figure, if you observe, there are 3 external points. So, those 3 external points are A is one external point, B and C. Those 3 are 3 external points. So, external points are there so that the tangents drawn from external point of a circle are equal. You are aware of that. Let us have this point of contact is equal to, already we used D and let it be some E and let it be F. So, these 3 are 3 points of contacts. We know that B is an external point so that the tangents BD as well as BF both are equal. So, it is 6 centimeters, this is also 6 centimeters. And from C, CD is one tangent and CE also one more tangent, so that CD is equal to CE, this is also 8 centimeters. But in order to find the length of AB as well as AC, you must know about the length of AF as well as the length of AE. But you can observe that AE is an external point, so that AF is equal to AE. We do not know what are the lengths. Let the length of AF is equal to AE is equal to X. So, now our primary task is to find the value of X. So, in order to find the value of X, then what is the strategy that you are going to apply? See here, ABC is a triangle, so that we can go with the area of triangle. What is the formula for area of triangle when all the 3 sides are given? Yes, by using Heron's formula. We already discussed in grade 9 12th chapter. Have you remembered? So, we have concept called Heron's formula. There we discussed and derived what is the Heron's formula when 3 sides of the triangle are given, right. So, as per Heron's formula of area of a triangle, when you know all the 3 sides AB, BC, CA, let us have first side AB is equal to some small a, BC is equal to small b, CA is equal to small c. So, then I am taking the sides, let AB is equal to small a. What is the length side AB here? AB is equal to x plus 6. So, this is x plus 6 centimeters and BC is equal to, for example, small b. But what is the side BC? 6 plus 8. What is 6 plus 8? Which is equal to 14. And what is side CA? Side CA is equal to suppose small c. So CA is going to be 8 plus x or x plus 8. So these three are three sides. So when the three sides are given, then area of a triangle by Heron's formula. So by Heron's formula for area of a triangle, what is the formula for that? Area of triangle equal to square root s into s minus a into s minus b into s minus c. And what is s here? S is going to be the semi perimeter of the triangle. Okay. So how do you find semi perimeter? S is equal to a plus b plus c whole divided by 2. Let us try to find what is the semi perimeter of triangle. So S is equal to a plus b plus c by 2. A is equal to x plus 6, b is equal to 14, c is equal to x plus 8. I am going to substitute. So x plus 6 plus 14 plus x plus 8 whole divided by 2, which is equal to, see here, this is x plus x equal to 2x, 6 plus 8 equal to 14 plus 14, 2 times 14. So 2x plus 2 times 14, can I take one 2 common? Then I would say that x plus 14 whole divided by 2. So 2 and 2 gets cancelled. Finally, I got x plus 14 as the semi perimeter of the triangle. And then what is the area of a triangle? Therefore, area of triangle ABC is going to be square root. Substitute in this formula. S into, S means x plus 14. So x plus 14 times s minus a means x plus 14 minus a means what? X plus 6. But you have minus before x plus 6, so that you will have to multiply x and 6 plus 6 with minus. So minus into x is minus x, and minus of my plus 6 equal to minus 6, that is s minus a into s minus b. Again s is equal to x plus 14 minus b, b is going to be 14 into x s minus c, again x plus 14 minus what is c here? C is equal to x plus 8. So that minus x minus 8. Hope you understand this substitution. Now let us simplify this, which is equal to square root x plus 14 was already there times, see if there is any cancellation, better cancel the terms. So minus x plus x cancel, 14 minus 6 is equal to 8. Here minus 14 plus 14 gets cancelled, you left with only x, and here minus x plus x cancel, 14 minus 8 is equal to 6. Right. So this is what area of a triangle ABC by Heron's formula. Right. Now see here, we did not get the value of x directly. So it means you need one more information in order to find the value of x by this triangle. See, by using Heron's formula we found area of a triangle. But is there any other way to obtain the area of a triangle? Yes, of course, if you think logically, we can identify one more way to identify, to obtain, to figure out the area of a triangle. So what is that one more way? I am going to join this O and B as well as going to join O and C. See, there is a triangle OBC. So in this triangle OBC, base is equal to BC, OD is already the perpendicular, because OD is the radius drawn perpendicular to the tangent, so that we can find out area of triangle easily by half into base into height. So similarly, if I join O and A, see, when I join O and A, and when I join O and P also, this OP is again the radius is perpendicular to the tangent through the point of contact. So I can easily figure out what is area of triangle AOB. Similarly, I can find the area of triangle AOC also in the same way. When I add all the three triangles, I would get what is the area of triangle ABC. So that is the other way to find out the area of triangle ABC. So I am going to write that, and consider triangle ABC. Area of triangle ABC is going to be, let us start from here, area of triangle AOB, area of triangle AOB plus what is the second triangle? Area of triangle BOC, area of triangle BOC plus third triangle is area of triangle COA, area of triangle COA. Now I am going to find their areas. Area of triangle is equal to first AOB triangle. For this triangle AOB, base is equal to AB, altitude is equal to OF. But what is this AB here? AB is equal to x plus 6. So that half into x plus 6 times, of course, altitude is always the radius in this particular figure. So what is the radius here? Radius is equal to 4. So this way we can find area of triangle AOB. After that, what is the second triangle? Area of triangle BOC. So half into, for a triangle BOC, the base is going to be BC, that BC is equal to 6 plus 8 is equal to 14, into height of course that is 4 centimeters, plus half into area of triangle COA. For a triangle COA, base is equal to AC, that is x plus 8, so into x plus 8, and what is the height? Height is going to be 4. When you observe in these three different terms, half, so half is common, 4 is also common. So can I take half into 4 common? So half into 4, remaining terms here x plus 6, plus here only 14, and here x plus 8. Got it? Which is equal to, here 2 1s and 2 2s gets cancelled. This is 2 times x plus x is equal to 2x, and 6 plus 8 equal to 14 plus 14 equal to 28. But if you can take 2 common here, then it would be 2 into 2 times remaining here x plus 2, how much are 28? 2 14s are 28. So this is again area of triangle ABC only. So in two ways we found area of the same triangle, right? So this is area of triangle ABC, and this is also the area of the same triangle ABC only. So what should be done here? Can we equate both the areas? Of course. So that when you equate both the areas 1 and 2, see here the area is square root x plus 14 times 8 times x times, what is that number? 6 is equal to, what did you get here? You got 2 into 2 is equal to 4 times x plus 14 is equal to 4 times x plus 14. So in order to simplify this, I should square it on both the sides because you have a square root here. So when I square it on both the sides, then square and root gets cancelled, left with x plus 14 into 8 into x into 6, which is equal to, when you square right hand side, 4 square is equal to 16 times x plus 14 whole square, right? 1x plus 14 can be cancelled, and then 8 1s, 8 2s are 16, 2 1s, 2 3s are 6. So finally left hand side you have 3 into x is equal to 3x, and right hand side you have x plus 14, right? So 3x is equal to x plus 14. When you transpose x towards left hand side, it would be 2x is equal to 14. 2 into how much is equal to 14? 2 into 7 is equal to 14. Therefore the value of x is equal to 7. After getting the value of x, what do you want here? You need to find the value of AB. So what is the value of AB here? AB is going to be x plus 6. X is equal to how much? 7. So 7 plus 6 is equal to 13 centimeters is the value of AB, as well as in order to get the value of AC, AC is equal to what? X plus 8. X is equal to 7. So 7 plus 8 is going to be 15 centimeters. So this way we can answer this problem easily, and this is what is all about the concept called circles. Of course, I strongly believe in that this is one of the very interesting and easiest topic which is there in our plane geometry. Of course, you also enjoyed this class. If I am not wrong, thank you.